All right, we're going to do an introduction, excuse me, an introduction to z-scores in this video. Now, we just finished with the normal distribution where we talked about the mean was in the middle, and then we added the standard deviation to go to the right, and we subtracted the standard deviation to go to the left, and we had values written all over here. Well, z-scores is a way to normalize our data. You can't compare apples to oranges, but if you change everything to z-scores, where it's based off of the mean and the standard deviation, then you can compare z-scores. So what that means is we give our mean a z-score of 0. And then to the right, we would add a standard deviation of 1 would give us a z-score of 1. So if you're thinking in terms of the empirical rule, between -1 and 1 would be the 68%. From -2 to 2 would be the 95, -3 to 3 would be 99.7, and so on. So z-scores are simply a way to normalize our data and allow us to find more probabilities than just those few with the empirical rule. Because remember, with the empirical rule, we had to be right on the standard deviations in order to be able to find anything. Well, with z-scores, we can have a z-score of like 0.6, and we can find probability based off of z-scores that are not perfect whole numbers. So how do we find z-scores? Well, a z-score is found by the formula. Let me find a color here. Z equals the value minus the mean divided by the standard deviation. So in words, right, value minus the mean over the standard deviation. So you know in all of these problems we have the mean and the standard deviation. The value is what we're trying to find. So let's do some examples because this formula will probably make more sense if we actually do some math with it. So the average adult male is approximately 70 inches in height, and we're going to use a standard deviation of 5 inches. So we can see that we have a mean of 70, standard deviation of 5. And those are the symbols. Like a cursive M stands for mu, which is the average or the mean. And the little curly Q is sigma, which is standard deviation. So if we want to find the z-score for a man who is 65 inches of height, we know that the z-score is the value minus the mean over the standard deviation. We have the mean and the standard deviation here. This 65 would be our value. So z equals value minus the mean over the standard deviation. Make sure you do your numerator first. 65 minus 70 is -5, divided by 5 is -1. So if we're talking about the normal curve, we know that the z-score of 0 is the mean down the middle, so this particular man would be here. This is where he would fall, below the mean. All right, number 2, let's find the z-score for a man who is 77 inches in height. Well, this is our value. Value minus the mean over the standard deviation. So 77 minus 70 is 7. 7 over 5 is 1.4. So this guy, if this is 1 standard deviation, then he's 1.4. He's just past that to the right. Number 3, find the z-score for a man who is 6'2". Well, we know that the mean is 70 inches. Standard deviation is 5 inches. So we need this height, 6'2", to be in inches. Well, 6 feet, if we multiply that by 12, gives us 72 inches plus the extra 2 inches. This guy is 74 inches in height. So z equals value minus the mean over the standard deviation. 4 over 5, my z-score is 0.8. How tall is an adult male who is 3 standard deviations above the mean? Well, mean is 70. If we're going to go 3 above, 1, 2, 3, remember to get each one we have to add the standard deviation. So 75, 80, 85. So you can do it that one way. Another way to do that would be to say, well, 3 standard deviations is 15. Above the mean means it's added to the mean, and that also gets you an 85. So it depends on how your brain absorbs that. And number 5, what is the z-score for Yao Ming, a basketball player from China who is 7 feet 6 inches tall? He played for the Houston Rockets. He was pretty good. So 7'6". Well, 7 feet, multiply that by 12, gets us 84 inches, plus the extra 6 inches, means that Yao Ming was 90 inches tall. Jeez. So z-score, value minus the mean over the standard deviation, 20 divided by 5 is 4. Okay, so when we're talking about where would this fall in the normal distribution curve, well, that's the mean, a standard deviation of 0, because that's the mean. 1, 2, 3, 4. He's way out here. Remember, anything outside of 2 is unusual. The fact that he's at 4 means he is highly unusual. Yao Ming, highly unusual. And that's your introduction on finding z-scores.